2 to the 3x plus 13 equals 2 to the 7. This value equals that value. So if the bases are the same, the exponents have to be the same. 3x plus 13 would therefore equal 7. Subtract your 13. You'll get 3x. You'll get negative 6. When you divide off that negative 3, you will end up with x equals negative 2. Okay? The other option is to use logarithms. So I'll take log of 2 to the 3x plus 13 power equals log of 128. This will go to the front. You'll have 3x plus 13 times log 2 equals log 128. I'll then divide off that log. So these cancel. 3x plus 13 will equal 7. Your calculator can tell you that. And then you subtract 13. 3x equals negative 6. When you divide off that 3, x equals negative 2. Either way, you get the same answer. Okay, now we're going to do example 2, which is 9 to the x plus first power equals 27 to the x minus fourth. Once again, these two are both powers of a common base. This can be written as 3 squared. This could be written as 3 cubed. That common base is 3. So option 1, 9 can be written as 3 squared. The original exponent needs to go in parentheses. 27 is 3 cubed. So they both are powers of 3. Again, the original exponent needs to go in parentheses. This equals this. So if the bases are equal, the exponents have to be equal. So I'll go ahead and multiply that out. 2x plus 2 equals 3x minus 12. So subtract 3x. You can subtract either x, but that's what I'm used to. Okay, so we'll cancel the 1 on the right side. I end up with negative x plus 2 equals negative 12. Subtract your 2. Negative x equals negative 14. Divide off the negative 1, and you end up with x equals positive 14. Okay? Option 2 is again to use logarithms. So log of 9 to the x plus first equals log of 27 to the x minus fourth. These exponents will go to the front. You will have x plus 1 times log 9 equals x minus 4 log 27. I divided off the log 9 on this side. You could actually do either one of them. So this left me, these cancel. This left me x plus 1. This is x minus 4, and your calculators could confirm that that is 1.5. When you distribute that 1.5 through, x plus 1 equals 1.5x minus 6. So I'll subtract negative 1.5x. That leaves me negative 0.5x plus 1 equals negative 6. Subtract 1, subtract 1. Negative 0.5x equals negative 7. Divide off the negative 0.5. And your calculator would confirm that the answer is x equals 14. Questions? Never mind the previous remark about questions because I don't have class in here. That was a habit. Because 26 is not a power of 5, the only option we have is to use logarithms. So I'll take the log of 5 to the 4x minus first equals log of 26. This will go to the front. 4x minus 1 log 5 equals log 26. Then I will divide off the log on this side. All right, and that will leave me 4x minus 1 equals log of 26 over log of 5. Now, if you're going for an exact solution, you're going to want to isolate the x. The first thing you would do is add 1. So you'll have 4x equals log of 26 over 5. Log of 5 plus 1. And then you would divide off that 4. So, the end result is that x equals log of 26 over log of 5 plus 1, all of this over 4. I think I'm going to move this to make it look more palatable. All right, we will resume with this example. Previously, we had used common logarithms, but we use natural logarithms for powers of e. So I'll take the natural log of e to the 0.15x power equals the natural log of 14. Natural log undoes raising e to a power. So we would have 0.15x equals the natural log of 14. Then I would divide off by 0.15. Cancel, cancel, and x equals the natural log of 14 over 0.15. All right, and that is the exact solution. The decimal approximations, you would take the natural log of 14, hit enter or equal, and then divide by 0.15. Okay, I got something that rounds to 17.6 when I did it earlier. Next up, example 5 is 12 to the e 0.05th power equals 72. First order of business, divide off the 12. Because we want to isolate the e. So, these cancel, and e to the 0.05th power is 6. Take the natural log of both sides to undo raising e to a power. Or more the point, taking this and raising it to the e power, or raising it to a power of e. That's what you're undoing. Okay, you're undoing the fact that this has been raised to a power. So you end up with 0.05t equals the natural log of 6. Now you'll simply divide both sides by 0.05. So cancel, cancel, and t equals the natural log of 6 over 0.05. That's the exact value. If you take a calculator approximation, you would get 35.835. At least that's what I got. All right. I moved out a little bit in preparation for example 7. We're on example 6 right now. Again, you would take the natural log of both sides to undo raising this to a power of e. So you'll have 2x plus 1 equals the natural log of 15. Then you'd subtract 1. So you'd have 2x equals the natural log of 15 minus 1. Don't combine these. This is irrational. 1 is rational. They don't combine, so you have to keep them separate. Next, you'll divide by 2. So x equals the natural log of 15 minus 1 over 2. And that's the exact solution. All right. This problem is going to take a lot of time. Example 7. 5, the 2x plus first equals 6 to the x minus second. First thing you're going to want to do is use common logarithms because that's not base C. That's the textbook what the textbook we're using has you do. You use common logarithms. So, and that's a 6, sorry. So, I'll take this to the front, and you'll end up with 2x plus 1 in parentheses times log 5 equals x minus 2 times log 6. All right, I normally just do the one on this side, so I'll divide both sides by log 5. And these will cancel, and you'll end up with 2x plus 1 equals x minus 2 log 6 over log 5. Now, what you need to do next is get these x's to one side, like your written copy of this tells you to do. So, to do that, you need to distribute this out. So you'll have 2x plus 1 equals x times log 6 over log 2, because it's this times this and this times this in a distributive property, minus 2 times log of 6 over log of 5. So this was the result of a distributive property situation. So before you can go any further, you now need to get the x to one side. So I'll go ahead and subtract off this x term. And that's log 5. I apologize. Okay? You're going to have to do the same thing over here. Okay? Now, I'm going to put 2x plus 1. I'm going to put the 2x here. And then you'll have minus x log 6 over log 5 equals the 1, or plus 1, equals, this cancel, and you end up with negative 2 log 6 over log 5. Which I had gone ahead and made this into negative 2 times this. So I put the 2 on top. Now, here's the thing. Under the rules of logarithms, you should be able to take this thing up here and square it. So now you would have 2x minus x log 6 over log 5 equals, plus 1, negative, and you're going to have, that 2 goes up in the exponent, so you have equals negative. That 2 went up in the exponent, so log of 6 squared over log of 5. And then I'm going to go ahead and subtract this 1 as well. So 2x minus x equals negative log of 36 over log of 5 minus 1. Okay, oh, and I forgot the log 6 over log of 5. And the goal of all this was to be able to factor an x out of these two terms. 2 minus log 6 over log 5 equals negative log of 36 over log 5 minus 1. And then we're going to divide off the other factor so that we have x equal, or we're going to divide this off, 2 minus log 6 over log 5 equals negative log 36 over log 5 minus 1. We're dividing off the other factor. And doing the same thing over here. 2 minus log 6 over log 5. So, all this crap cancels, all that cancels. So we end up with x equals negative log of 36 over log 5 minus 1 over 2 minus log 6 over log 5. That's not the format your textbook normally prefers. So what we're going to have to do is we're going to have to clear the fractions using the LCD, which is log of 5. So we'll multiply everything by log 5. So negative log 36 over log 5 times log 5. The goal was to be able to cancel away the denominator, minus the 1 you still have, times log 5, all over 2 times the log 5, minus log 6 over log 5. Okay, I'm going to go ahead and erase the unnecessary parentheses. You can take this 2 coefficient, put it up in the exponent. So you'd have negative log of 36 minus log of 5 on top over log of 5 squared minus log 6 over log 5. Oops, I forgot to multiply this by log 5 as well. So those cancel, and I end up with this minus log 6. Okay. Now the next thing WebAssign is going to expect is to get to look like what it would look like in the Swakowski textbooks as well. Is go ahead and factor out a negative here. So you'd have log of 36 plus log of 5 on top. Down here, you would have log of 25 minus log of 6. As we approach the bottom of the problem. Using the sum product rule, you can convert this into the log of 36 times 5. You can convert this into the logarithm of a fraction, 25 over 6. So the end result would be negative log of 180 over log of 25 sixths. Okay? It's a long, time-consuming problem, and fortunately, it's the only one of its type in these examples. So the remainder of our examples will be short. All right, so here's example 8. It says a deposit of and if you have a printout of the file, you can read it even if you can't read this. A deposit of $550 is put into an account paying 4.2% interest compounded continuously. So the formula is A equals PE to the RT power. Okay? That's the formula that we would use because it's compounded continuously. If it said anything other than continuously, we use the other one, like monthly, quarterly, although annually. Those are the other formula for compound interest. So we're wanting the accumulated value to become 800. The principal, the initial amount was 550. E is E. 4.2% as a decimal is 0.042, and T is the unknown time that we have to find. So what we're going to want to do first is divide off the 550. The E expression remains the same. This reduces to, both of these are divisible by 50, so that reduces to 16 elevenths equals E to the 0.042 teeth power. Okay? Now we did these types of problems earlier without a word problem related. We want to get this out of the exponent. We will do that by taking the natural log of E to the 0.042 teeth power. We'll also do the same thing for the natural log of 16 elevenths. So that's a none, and you end up with 0.042t equals the natural log of 16 elevenths. Next, you want t by its lonesome, so you will divide off the 0.042. You'll do the same thing over here. All right, so I get my calculator. I will take the natural log of 16 elevenths. Make sure, if it isn't already in parentheses, make sure your calculator puts it in parentheses. Hit equal. Then divide by 0.042. You should have got approximately 8.92 years. Okay? So approximately 8.92 years. Okay? So that's A. Next up, we're going to do B. I think if I tilt this, I can fit them both in here. Okay, so here's B. B asked for the doubling time. That's the amount of time needed for any balance to double. So here the balance, we're going to double the balance of 550. We start with 550. We want to know how long it's going to take for it to double to 1100. Okay? The initial balance was still 550. E to the 0.042 teeth power. Then we will divide both sides by the 550. Cancel, cancel, and this is 2. Anytime you're asked for a doubling time, you're going to end up with a 2 in here somewhere. And then E to the 0.042 teeth power. As we did before, we're going to take the natural log. We're going to do that for the E. We're also going to do that for the 2. Okay? So that'll cancel. 0.042t will equal the natural log of 2. When we divide off that 0.042, we end up with t is approximately this value. So natural log of 2, hit enter or equal, and then we divide by 0.042. I got approximately 16.5 years. Okay? All right, so this problem is a similar type of problem, but it's got monthly compounded interest and compounding. So a deposit of $700 is put into an account paying 5.2% interest compounded monthly. Okay, that's monthly. That's not continuous. You would use A equals P times 1 plus R over N to the n-th power, and N, because it's monthly and there's 12 months in a year, N would be 12. Okay? So I want the time needed to reach $1,000. So I want the accumulated value to reach $1,000. The initial deposit is 700 times 1 plus 0.052 divided by 12, because N is 12. That 12 down here will also be up here. And the T is unknown. That's the question. Because this doesn't round cleanly, you're going to want to leave it the way it is. Because money is a very exact thing, especially in banking and investment companies. So we're going to have to divide off the 700. And that's going to be 1 plus 0.052 over 12 to 12th power. So this cancels, and this reduces to 10 sevenths. 10 sevenths equals 1 plus 0.052 over 12 to 12th power. Now, because this is not E, we're going to use common logarithms. So, log of 10 sevenths equals log of 1 plus 0.052 over 12 to 12th power. I guess I should put this in brackets to show that you're taking the log of all that. And that's going to allow you to take the 12t to the front. I'm going to try to move the podium a little bit. So, log of 10 sevenths equals 12t times log of 1 plus 0.052 over 12. You want to isolate the t. So you're going to do that by, well, I'm going to switch the sides here. So I'll do 12t log of 1 plus 0.052 over 12 equals log of 10 over 7, log of 10 sevenths. So I've just put this here, I put that here. You're going to want to isolate the t by dividing by 12 and this. All right, and you're going to do that to both sides. So I might as well extend the fraction bar all the way over. You're going to do the same thing over here. So t will be the only thing that survives over here, and these have to be replicated down here. 12 and log of 1 plus 0.052 over 12, close the parenthesis, and t will equal log of 10 sevenths divided by 12, and also divided by log of 1 plus 0.052 over 12. So, I'm going to get out my calculator. Log of 10 divided by 7. Close the parenthesis. Make sure that that part's in parentheses. Hit enter. You should be fine. Divide by 12. hit enter, and then divide by log, open a parenthesis if your calculator doesn't already do it for you. 1 plus 0.052 divided by 12, close the parenthesis. I got something that rounds to 6.9 years. All right? Because this is a longer problem, I'm going to need to erase it and start over. Okay, so now I will proceed to do B. Doubling time is simply a matter of that 700 becoming 1400. I want to know how long it will take for the original $700 to double to 1400. So accumulated value becomes 1400. And then I still have the 1 plus 0.052 over 12 over here. As we did last time, I'm going to try to, oh, sorry, I forgot my 12t here. As I did last time, I'm going to want to isolate the exponential expression by dividing out that 1700. So that's what I'll do. And as I told you about doubling time in the previous example, this is going to become 2. So you're always going to have a 2 anytime you have a doubling time question. And then this is still 1 plus 0.052 over 12 to 12th power. Okay? All right. I want to get the 12 out of the exponent, so I'm going to need to do a logarithm. And this textbook has you do common logarithms for anything other than base E. So log of the whole thing, 1 plus 0.052 over 12 to 12th power. And that 12t will go to the front, like it did before. And so I will have log 2 equals 12t times log of 1 plus 0.052 over 12. And I'm going to go ahead and switch the sides so that you see what's going, you're more familiar with that based on previous experience with algebra. So I'm going to move 12t log of 1 plus 0.052 over 12 equals log of 2. And then I'm going to divide off the 12 to isolate the t. I'm also going to divide off this part. Okay? If I do it here, I also have to do it over here. No problem. Okay? So these cancel, and the only thing left is the t. It's going to be equal to the log 2. Divide also by by 12, and divided by, I better put that in parentheses. That way, because some calculators put a parenthesis for you, and if you forget to close it, you got a problem. So let's just get used to keeping it in parentheses. So I'm dividing this by the 12 and also this. All right, so log of 2. Hit enter or equal, divide by 12, and then divide, hit enter or equal, and then divide by log, open a parenthesis, 1 plus 0.052 divided by 12, close the parenthesis. I got something that's approximately 13.36 years. All right, so this is the final example. A medicine is administered and then processed and eliminated by the body. for a dose of 14 milligrams, the amount A of T in the body after T hours is given as A of T equals 14 times 0.85 to the Tth power. It says something about the drug needing to be, for the drug to be effective, at least 2 milligrams are needed. That's irrelevant to questions A and B, so I went ahead and skipped putting it on the board. I'll save the space for the math that we need to do. So let's interpret this. Any exponential model has the original amount times the surviving amount or growing amount, if this was greater than 1, to the Tth power. Okay? So the initial dose was 14. After each hour, only 85% will remain. So 85% of 14 will survive after 1 hour. Over the second hour, another 85% will be remaining after 2 hours as there was after 1 hour, and so on. So we're interested in how long it's going to take for the remaining amount to be 9 milligrams. Well, we started with 14, and it's 0.85 to Tth power. So I want to isolate the exponential expression, or exponential component. So I will divide off the 14. And 9/14 equals 0.85 to Tth power. That's not base E, so we're going to use a common logarithm. And that T will be able to go to the front. If I do that to this side, I also have to do it to the log of 9/14. So I have T log 0.85 equals log of 9/14. So T log 0.85 equals log of 9/14. I'll simply divide off the log of 0.85. So cancel, cancel, and T equals log of 9/14 over log of 0.85. That would be what's called the exact solution, but for this to be practical, we're going to need an actual measurement. So log of 9 divided by 14, close the parenthesis. Make sure these are in parentheses if they're not. Hit enter or equal, and then divide by the log of 0.85. I got approximately 2.7 hours. All right, I'm going to need to erase the board to have room to do B. Okay, for part B, half-life is the amount of time it takes for the initial deposit, the initial amount, to become half what it was before. So we start with 14 milligrams. The half-life is how long it takes for that 14 to become half, which is 7. Okay? Half of 14 is 7. Half-life is how long it takes to get from 14 to 7. Half the original amount. So start with 7 equals 14 times 0.85 to Tth power. Now, similar to doubling time where you had 2 left, here you're going to have, or 2 at some point. For doubling time, you had 2 somewhere in there. Here you'll have half. So I divide off that 14, and that's where that half will come from. So they cancel. This is 1/2, or 0.5. It's a terminating decimal, so I'll just use the decimal. Time equals 0.85 to Tth power. Well, that's fine. We're simply going to take the common logarithm and we're going to do that to this side. We're also going to do it to the 0.5. t will go to the front, so I will have t log of 0.85 equals log of 0.5. So I'll just copy it over here. And then I want to isolate the t, so I'll divide off the log of 0.85. Cancel, cancel, and t equals the log of 0.5 divided by the log of 0.85. As an approximation, I take log of 0.85 to log of 0.5, sorry. Hit enter or equal, then divide by a log of 0.85. T is approximately 4.265 hours. And that is all 10 of our examples in 2 parts. Okay, this example is being recorded about a year after the other examples. Hence the reason for the different close, hence the reason for the different room. So I've already taken the time to put the example on the board. It may not have the exact same wording as your paper, but it's the same question. Now, folks, half-life. So first of all, A, I forgot this part. Give it in days, and B, convert 2 years. Forgot that, okay? The half-life, folks, is the amount of time it takes for half of something to be gone, okay? If it follows an exponential decay law, which this one does, okay? So what we're looking for, we are looking for time it takes for the original 420 micrograms to become half of what they were, which is 210 micrograms. Micro is metric for millionth. So a microgram is a millionth of a gram. A micrometer is a millionth of a meter. Okay? Or a thousandth of a millimeter. So, this doesn't look like quite like a half. It looks like a half. Okay, that should be clear. Okay, so if it's A of t equals A sub 0 times e to the negative 0.00012t, then we're looking for the original amount is 420. We're looking for 210 to be the amount after the unknown amount of time. And this is e to the negative 0.00012 or 0.00012t, okay, negative. So I want to isolate the e expression. So I will divide off the 420. Okay? Like so. These cancel. And folks, that's 1/2 or 0.5. Okay? In fact, I'm going to switch the sides here. This gives me e to the negative 0.0, sorry about the handwriting, negative 0.00012 power is 0.5. Okay? The next order of business is we want to get this out of the exponent, so we're going to take the natural log. Of both sides. Log base e of e to a power cancels, and this comes out of the exponent, giving me negative 0.00012t equals the natural log of 0.5. Next up, I want to divide both sides. So negative 0.00012t divided by negative 0.0012 equals the natural log of 0.5 divided by negative 0.000, that's 3 zeros, both sides, like so. So this is going to cancel, and t is approximately. So what you're going to do is you'll need a calculator for this. You're going to take whatever sequence you do to find the natural log of 0.5. You should have negative 0.69 something, 6931, blah, 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 blah. Now, that's for this part. Then you would divide by negative 0.00012. So natural log of 0.5 is 0.693, blah, 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 and then divide by negative 0.00012. Okay, I got approximately 5776.2 days. Okay, so next I'm going to do part B. Part B I'm going to take those 5776.2 days and divide it by the 365 days in a year. Okay, so I'm going to be taking these and grouping them into clusters of 365 days. So 5,776.2 divided by 365 is approximately 15.8 years. Okay, that's it.